So, before I start this video, I want to remind everyone that quarantine is a thing and getting a hold of certain research items takes more time than normal, and I had to do a lot of extra confirmation. I would like to personally thank Tex of the Black Pants Legion for providing me with some oversight to make sure that I got this as close to correct as possible. I started searching for science videos on things that I could possibly do research on when I stumbled across that people had begun doing, well, fusion energy may be coming. And in my little Battletech-y brain, I went, is that so? And second, it turns out that you can build heat sinks as absolutely big as you want. And I'm sitting there and I'm going, okay, well, according to Sarna, Battletech's wiki, which is by far the best wiki in existence, trust me, there is no amount of information that you will ever need that is not on Sarna. At least for Battletech. Says we're only a year away from creating a sustainable fusion engine. Not a reactor, an outright engine. Well, according to Papa Media and Science Research, we are very close to creating a fusion reactor. I decided to sit down and take a look at what it would take to make the self-sustaining fusion engine that is required for Battletechs, Battlemechs, aerospace fighters, and really obscenely heavy vehicles to function. I started down a rabbit hole that has taken 4 months between moving, resettling, and research time and the quarantine's interference with said research to find out everything I needed to know to make this video comfortably. Understand, this took a solid month of reading and another solid month of calculations, formulas, and additional research into this subject. You will find several books mentioned and several dozen sources in the description below. The description below will contain my entire bibliography. Yes, I read all of this information. So understand, this is going to be a long video. It's going to be a long science video. So go pause the video, go make yourself some popcorn, get a root beer. I personally like IBC because sugarcane root beer is amazing, and IBC is still the best root beer I've ever had. Or if you can find it, go get some Mexican Coke that's made with sugar, not corn syrup. Trust me, you'll enjoy it more. And I'll wait a moment. Are you back? Cool. Now let's pose a very serious question. Can we build a Battletech Battlemech? Not should we, but could we? And while I'm not going to beat around the bush, let's dive in and find out. What makes a fusion engine or a fusion reactor work? Well, to know that, we need to know what makes a fusion reactor work. I'm going to attempt to explain this in the most straightforward terms possible that will not require you to take 16 hours of nuclear physics or have a degree on the subject. You take an atom of hydrogen composed of 2 hydrogen atoms, commonly referred to as H2, or deuterium. Yes, that is in the material that Star Trek, that Geordi is constantly ranting about in his warp core. Warp cores are fusion engines! You take an element of hydrogen composed of 3 hydrogen atoms, commonly referred to as tritinium. Yes, the other thing that requires to function in a warp core to make antimatter. No, they didn't entirely make it up. Battletech and Star Trek greater than Star Wars. Prove me wrong. Now, that all the keyboard warriors are in the comments trying to explain to me why Star Wars is better than either of these two things, or why the Star Wars wiki is somehow better than the Battletech wiki, go ahead, I'll wait. You put these atoms under immense pressure and heat that equals the core of the sun. Yes, I said that correctly. Around 100 million degrees Celsius. Then, with this pressure and confinement, They fuse and ram into each other at such high velocities and create baby atoms called neutrons. Neutrons are a small piece of an atom being comprised of neutrons, protons, and electrons. Neutrons are neutral, protons are positive, and electrons are negative. These neutrons produce massive amounts of energy when they are released this way and bounce everywhere, and you use this energy to provide electricity. Under the right circumstance, there is enough energy produced to create cascades of plasma. Yes, the stuff that stars are actually made out of. Before you keep all of it contained in giant magnets. All of this will be used to drive a turbine. The plasma either generating steam or being directly filtered through a turbine that is made of sufficient material to withstand the heat of plasma. This is exactly how Star Trek claims to generate electricity. That's what's coursing through those big tubes with all the lights and things, and that's what's supposed to be coursing through it whenever you're crawling through a Jefferies tube. It's not space magic, it's science. Reference number 26. That is the short, bare basics of nuclear fusion. No, it does not produce radioactive materials. It produces hydrogen and oxygen, as well as a fusion of neutrons that literally fuse together to form new atoms to run the energy reaction. No, it does not explode when you blow it up. Fusion reactors do not explode. This is not a fission reactor. No, it doesn't cause nuclear disasters when it breaches. When a fusion engine is breached, a bunch of plasma leaks out, does some immediate burning, and then the reaction stops because of the lack of heat and pressure to sustain the reaction. Once you put out the fire, all the danger is gone. Nuclear fusion, unlike nuclear fission, is safe. Learn the difference. Now, we're going to get into the self-sustaining fusion engine, the biggest hurdle to creating a big stompy robot with PPCs. At the current version of fusion energy, we can only generate an efficiency of 0.6, referenced to be Q equals 0.6. You will find this in my first through third references down below. That means we're only getting 60% of the energy we put in to the reactor back out of it. That means that 60% of the electricity it takes to run the reactor is all that it's outputting. It's a cascade failing reaction that eventually stops without more input. In order to achieve commercial viability, we need to get 1,000% energy output, or Q equals 10. So, at present, we're only generating 6% of the power needed, 0.6% of the power we need in order to, not even 0.6, it's a lot less. It's an obscenely low number. It's 0.06% of the power we need to create a commercially viable nuclear self-sustaining fusion reactor. I haven't even got to the self-sustaining part. So we have a very long way to go, but the biggest problem, biggest challenge is funding. Trying to convince people that nuclear fusion isn't nuclear fission is a political hot-button issue. Because unlike a fission reactor, when a fusion reactor is breached, it just shuts off. It just stops. Remember in SimCity 2000? Remember back in the 90s when we played SimCity 2000 and you built a nuclear fusion reactor when it came to 2040 and it was literally the most efficient power plant in the game and it didn't explode when it blew up and it didn't cause nuclear fallout and it was amazing? Yeah, that's the difference. SimCity 2000 got this right in fucking 1997. The other issue is tritanium, or helium-3, represented in chemistry by H3. Big H, little 3. All the other names for it, there are a bunch of other names for it. Naturally, it has a half-life of 12.3 years, meaning it is likely to expire before it gets used. However, we do have ways of making it. The issue is that a 500 megawatt power plant is required to make 50 kilograms of the stuff every year. Why do we use 500 megawatts? Because that's what a natural gas or coal power plant is expected to output, is 500 megawatts. So if we had a single power plant devoted to breeding helium-3, we would only make 50 kilograms. Now, we are looking at ways of making the reactor self-breeding. What that means is when the reactor gets its helium-3 input, it outputs helium-3 back as its waste product. So it goes through the process of fusing all of these helium-3 atoms together, and then on the output breaks them back apart in order to create a self-breeding reaction so that the helium-3 that is used is then cycled back through the reactor and it creates more of the stuff it needs to continue running. Just so you're aware, currently the only fusion reactor that can produce helium-3 only makes 3 kilograms a year. It needs to make 50 kilograms per year to become self-sustaining. That's why that 50 number is there. This is reference 3. That's, as a second note, Canada and South Korea are ahead of everyone on this. The United States of America is actually not even on the chart when it comes to breeding helium-3 or creating a fusion reactor. That's right, America. You are behind on development so badly, you don't even have any research going for this. Canada is beating you to this. Go Canada. Seriously. Canada could... How could you let Canada lead you in a scientific field? But then again, you know what? Screw it. I will totally welcome our maple syrup overlords if it means that I can have self-sustaining fusion reactors. Anyway, we get all of these problems solved and miniaturized down to fit into a Battlemech or tank, and then boom, we have self-sustaining fusion engines. Using a turbine that is powered by plasma and the stars themselves. Eat it, son. We figured out how to artificially replicate you. In like 50 years. 50 years later. Then Battletech did it. Took us 50 years longer. Braggle fraggle. Suggest writing politicians to convince them to use nuclear fusion if you want to see this sooner. That, or get insanely wealthy people like Elon Musk to make a self-sustaining fusion reactor as a meme. Now, the next issue with Battlemechs. Can a mech lift? We're going to talk about Myomer. Myomer is described as thick bundles of fibers woven together and then having huge amounts of electrical voltage surge through them to act like muscles of a human body. I thought, okay, that's so futuristic that... Reference 5, Fiaura. Reference 5. Okay, you know what? Okay then. And then I thought, perhaps it's not exactly 100% there. Well, it turns out this is from 2016. Yeah, we've been distracted with the world burning down around us. Sweden has quietly developed cybernetic arms. The United States only started experimenting with this in 2018. This uses fiber bundles powered by electricity on a heavy-duty battery. Yes, humans can't generate enough electricity, so you do have to charge these every night. But it's Myomer. It's literally human-scale Myomer. It is exactly what we are looking for. It is mech muscles. They're built. They're ready to go. They work. It's all right. Ghost in the Shell and Shadowrun. Here we come. I want a cyber limb tomorrow. I want to be able to punch through cars. What do cyber limbs have to do with Battlemechs? Everything. These arms are so adept they can reach... You can apparently play the piano with them. Maybe only one song, but you can already play... But a person's already able to play the piano. Alright! So, we solved the problem of Myomer with artificial limbs and are getting scary good each year. Now we have another major issue, the Neuro Helmet. What do I mean by the Neuro Helmet? It's more machine than man, right? What the hell's a Neuro Helmet? How does that work? Neuro Helmets are those things mech warriors wear on their heads. Reference 7, 7A, and 7B. They allow the user to directly interface with the mech and its controls. Think of it as being able to feel the arms, legs, fingers, and toes. The computer system reads the neural process of the pilot and translate that to what the pilot means when they move the analog controls. This can be the difference in moving a single digit of a finger on the mech to give a thumbs up to raising a Gauss rifle to fire. Without this, you would need a control box that looks like this, reference number 8. This is from the game Steel Battalion, and it has 44 input options, 2 joysticks, a throttle, a radio, 5 additional power and secondary switches, an ejection handle, and 4 and 3 foot pedals. A working version of these controllers is $2,000 on Amazon right now, reference 8A. This is a video game, and with some of the controls of a mech aggregated to be assumed. That's right, it's still aggregating them to be assumed, not directly inputted by the pilot. I want you to imagine that your mech, even with this, could not perform the delicate maneuvers, such as gripping onto a tree without crushing it and then using that tree to smash it over another mech's head. Wait, what do you mean delicate? That sounds pretty not so delicate. Actually, the act of wrapping your hand around a club is entirely a damn delicate process when it comes to nature. Rather than a full biology book you might not completely get, here, have this from the Boston Globe, reference 9. Now have this from Quora, Popsy, and Cosmos, reference 10, 10A, and 10B. Are you starting to grasp the issue? Yes, I did all of that for a pun. Let me explain. So humans, grasping something is the evolution that took millions of years of natural development. And if you notice, only a few creatures have managed to properly master the ability to wrap an appendage around something and manipulate it finely. Elephants can do it with trunks. Chimps and apes use their hands, which are really just feet with extra digits, let's be honest. And almost every other creature, everyone else uses their mouths. Yes, grasping an object is that hard. Now, with this in mind, how difficult is it to create something completely artificial to make the size of a car, roughly the size of a Highlander Battlemech hand, to be able to pick up a person without crushing them? Oh boy! We're in for a trip. The brain sends 1,640 signals from your brain to your hand to type a single character on a keyboard page. As of writing this, my brain has put in 18,527,080 signals to finish this sentence as a part of the script. That's not even the whole script. I'm on page 5 out of 18. A computer must translate all of those signals into a user interface. In the case of a mech cockpit, the joysticks and the buttons on them in order to grip those mech digits around a person. Then it must give me, the pilot, the user feedback to indicate I have grasped the person well enough they are not going to fall or slip out of the fingers of my mech, but I have not gripped them so tightly that I have turned them into new squishy red mech paint. A real-life example of this you can perform at home. Get a paper cup, a soft plastic cup, a styrofoam cup, a wine glass, a hard plastic cup, a glass, and a coffee mug. Fill them all with water to where you expect them to be filled if you want to drink from them. If you don't have all of this, that's fine, but I'm sure all of you have experienced these different glasses and different ways of drinking from. Now, just so long as you get at least 4 out of 7 of them, then pick each one up. Notice how you, an adult watching a Battletech video, pick up and apply different levels of pressure to all the cups. Notice if you were to pick up the paper cup with the same strength as the coffee mug, you would crush it. The paper cup is a person. The coffee cup is a bundle of endosteel I-beams you are helping move. The tree is probably somewhere around the wine glass. Still hard enough to be painful if you hit someone with it, but completely unlikely to survive intact being dropped or someone hitting it. That is what the neuro helmet is trying to decipher. The computer needs to know the difference when you move the joystick. Am I moving the wrist, middle finger, gun mount? Does that button mean shoot, thumbs up, or thumbs up at the target? This helmet isn't measuring muscle movement, it's measuring intent of the brain signals. That's why it's a neuro helmet and not a muscle reactive exoskeleton. As it takes the paste, slime, and gels that make up the hormones washing over your brain. The electro signals and everything else the human is doing translates it into computer code to understand how to move the individual Myomer bundles, joint actuators, and whether you intend to grab, punch, wiggle digits, give a signal, or shoot at something you're looking at. Okay, so how close are we to this technology? A really, really long way. At present, the closest we have to this with neurological implants is to stimulate deep coma patients to try to get them to wake up, or for the completely disabled to be able to use a computer in a very primitive way. Reference 11 and 11a. This is a few hundred piles of electropolymer and enough chip equipment to equal a small laptop just to get the mouse to move on the computer screen for this quadriplegic. Oh, did I forget to mention that this is installed directly into the brain and the blood vessels that run through your brain? Yeah, there is that. This requires brain surgery to put in, whereas the neuro helmet just requires anyone to put it on. And the brain surgery might kill you or leave you completely crippled or catatonic for life if it's done incorrectly. We're a long way from taking a CAT scanner or an EKG and being able to read neurosignals and emotional intent without having to have hardware actually put into our bodies. Hardware that does wear out and require replacement. Did I also forget to mention that part? You have to have this brain surgery multiple times over your life to keep the hardware going, and if it wears out or goes bad, it has to come out or it poisons you to death and kills you. So the neuro helmet is one obstacle that we're not even close to solving. Not without dedicating hundreds of bodies of science and trillions of dollars into, which would require us to need to do that. Next thing, how many? 1 pilot, 2 pilot, 3 pilot, 4. How many pilots do you actually need? The neuro helmet brings up a good point. We see movies like Pacific Rim. They claim that the machines are so large it requires 2 brains to operate. So you're saying this is so complicated it requires 2 of the most complex computers ever seen. Literally, your brain is a more complex computer than the best supercomputer in existence. Pat yourself on the back for being human. The answer to Pacific Rim? No, there is no way you could link 2 human brains together and get them to function in sync, not without killing the 2 people in question. The claim that kaiju have 2 brains is just science fiction. It's more like an octopus having a brain that controls everything while having additional pieces of brain that act like electrical substations, really. Not the power plant that's powering the whole entity, but the electrical substation that links the power plant to the homes and gets the proper amount of power or reboosts the signal to send it back out. It's not a second brain. Science fiction movies, please stop leading people astray by making people think that dinosaurs and octopuses have multiple brains. They don't. Reference 12. So, Battlemechs would need to require 1 person to operate. The idea of VR headsets helping, as well as a neuro helmet solving the problems of scanning intent and purpose of each joystick movement, pedal press, and button activation, would be more viable. We can already read brain activity, detect brain waves, measure hormones in the brain, as well as determine electrical impulses that are sent from the brain as a conscious effort versus a subconscious one. This is the difference in breathing and telling your arm to move. Reference 13. So at the end of the day, we just need to develop technology to measure these to the point that they can detect the slightest subtle hint of brain activity and how it should translate into computer code without that code being compromised by EMP radio signals or a virus. All that said, we might be closer than we think. Just take VR Stack and use it as experimentation until we can read everyone's brains. Now, big question. Ice, baby, ice, you're under pressure. Heat sinks and other cooling options. Okay, open your computer. Just kidding. That would require you to stop watching the video and actually take the panels. But if you've ever opened one, you've seen this big metal device in your processor like this. It's called a heat sink. The way a heat sink works is it draws heat up into those fins to increase the surface area that the fans are blowing across. This is a basic principle of physics that if you increase the surface area, you can increase the area that can be affected to cool it down. I feel like I shouldn't have to explain this, but okay, scientific reference number 14. Yes, I understand a reference for the basics of thermodynamics for dummies, because I know you guys might actually challenge me on this if I don't start with the bare bones. Looking at you, Eldar. Fanboys. Moving on. The way heat sinks work is they draw the heat up and create a larger surface area for the heat to dissipate systems. Fans and tubes run full of coolant to radiate over them and keep cool air running over them. And by drawing them up into these little fins, you drastically increase the surface area that it can be applied to and drastically increase the amount of thermodynamic energy that can be transferred between the air around the heat sink and around the processor and the computer. So it should be noted that this assumes an air-cooled system. Heat sinks in a water-cooled system would be, well, probably redundant or cool significantly more effective. We've never actually experimented with putting heat sinks into water. I just want to point out that putting water into a system of joints that are covered in oils, gears, actuators, bundles of Myomer, and tons of electricity, as well as hardened stiff metal parts, is probably a terrible idea. Why is this a bad idea? Well, I would say throw your root beer you grabbed before this over your computer, but then your computer would die. Let's just say circuit chips and electricity and water aren't good bed pillows. But even in a water-cooled system, you'll notice the water is contained in tubes run through a radiator, which, if you look at the radiator, looks like a really stretched-out heat sink that doesn't have fins, but rather extends through and has the water run around various metal parts that are absorbing all the heat. So massive heat sinks, to sink the heat generated by lasers, particle projection cannons, autocannons, and missile racks, the heat sinks would need to be against the weapons to soak up the heat into them and then dissipate the heat outward. The question is, does supersizing an object, in the case a heat sink, result in better cooling? The answer is yes. Reference 15. I'm surprised by this, but unlike cannons, ships, and other things we make too big that don't really work anymore, such as, at a certain point making a ship too big, the metal just can't take it and falls apart, you can make a heat sink as big as you want. It straight up works. You can make a heat sink the size of a car. I mean, we haven't built a 1-ton heat sink yet, but again, we haven't invented a death laser either. Reference 16. At least we haven't made one for the express purpose of killing people yet. Holy cow, that industrial laser is cutting 200 kilogram has a 200 kilogram heat sink. Okay, then we might have built a ton or two of heat sinks very soon to get industrial grade lasers that can print cars. That's actually a thing that came up over the course of this research, that cars might be printed by lasers in the future. Okay, now I'm going to get into one of the key features of Battlemech's damage control, operating with broken biddies. One of the key features for a Battlemech in Battletech is their endurance. A tank is destroyed when any section is destroyed with its internal structure. Mech-sized flamethrowers can cook the tank and crew from the inside out if they're not environmentally sealed. Only mechs can survive having a section blown clean off. Why is this? Because mechs rely upon their engine, gyro, legs, and pilot to function. You can blow off arms, weapons, sections without engine bits, and all of them, and the mech still works. However, the fact is a mech with only one leg should fall over. Think about it. We as humans have a hard time balancing on one leg. Now try to balance on one leg while someone punches you as hard as they can in the chest. You're going to fall down. Battletech resolves this by the damage transfer, but in real life you would just blow the leg clean off. Reference 17. So how would a mech operate with broken bits? It wouldn't. It would be considered mission killed if even an arm that contained no weapons and literally was just used to shield the mech, I'm looking at you, Centurion, reference 18, were to be destroyed. So keep this in mind moving forward with Battlemechs. It's better to retreat and save the equipment than to push and end up with busted parts. Go play any Battletech game and look how annoying it is to replace parts that get smashed if you're playing a long-term campaign. PPCs are expensive. However, here is this. If you build these incredibly super complicated weapon systems, you're going to want to make sure that you are prepared with redundancies and prepared to tell pilots to continue or not. So be careful when designing your work to contain things like mechs that keep fighting despite their machines obviously falling apart around them. Endurance is the advantage to mechs, and it would be the advantage to them in other forms of combat and in real life. A sabot round punching the mech's torso probably didn't kill it. But at the same time, a company of tanks can put out a lot of Sabo rounds much faster than a single mech. Can a mech walk? Can it stand? Does the metalgary, armor, supporting structure, and Myomer say that 100 tons can run around? Okay, I figured I would answer a couple of sub-questions concerning mechs now rather than attempt to do so later. Could you really build something that weighs 100 tons? It is 3 stories or roughly 7 to 11 meters tall, and it simply doesn't collapse under its own weight when it tries to walk. Yes, the answer is yes. Here. Japan is building an actual Gundam. And it walks. They've made it move. So, yeah, you can. It's only 25 tons, but you can do it. It's plausible. We also have to give another example of something that weighs an excessive amount, that has to deal with an obscene amount of stress at small localized points. We have to build ships to account for rogue waves. Ships that weigh hundreds of thousands of tons in some cases. By the way, these ships are also in metric tons, just like in the Battletech universe in all scientific notation. NASA did go to the moon. Yes, they did it. They used the metric system. They then translated metric to imperial for the general public. In the military, they used the metric system as well. I couldn't spell this out for you any clearer. Anyone who doesn't know metric, the military and NASA laugh at you. Battletech uses metric. Get used to metric. Now that I've triggered a bunch of people, moving on, tangent aside. We have to design ships that can cruise over the ocean and withstand the forces of having incredibly small sections of that ship be the only thing that's actually able to support the ship from falling into the water. These designs have to go through rogue waves and ocean storms, sometimes with several hundred metric tons of weight in a very, very tiny place. All of this without the ship tearing into or ripping itself apart. In 1995, the ocean liner Queen Elizabeth II was struck by a wave that was the size of a 9-story building. The ship was crippled, but it did not sink. The pressures involved on that vessel are several tons per cubic meter times the force of gravity. So to answer your question, if modern engineering can get something that weighs 100 tons, is 3 stories tall, to move around bipedally, the answer is yes. The metalgary and support structure is entirely plausible. 100 tons is a joke to a shipbuilder. And that's just a shipbuilder operating on water. And water is a lot more fickle than solid ground. There are reasons we don't yet, but I could get into that theory. But anyway, the rogue wave exerts roughly 100 to 200 metric tons per square meter of force on the ship. Ships are designed to tolerate 15 to 20 tons per square meter minimum. Ships can survive these, and yes, they may be broken, disabled, or punched through in some cases, reference 20. But keep this in mind, we can, in theory, build a solid set of legs for a mech that is self-supporting and able to support its own weight, and we already have a Gundam that weighs 25 metric tons walking around. So, there you go. Another quick example of this is a mega skyscraper crane is in excess of 30 stories, can weigh as much as 300 metric tons, and is able to lift 25 metric tons at a time. So no, I firmly believe we have the metalgary and understanding of how to build structural integrity to make something like this walk around. Next question that's going to come up. More than one weapon really better? Multiple weapon systems versus single main weapon, depending on the weapon system. You notice modern vehicles have one main gun, but in case of infantry support vehicles, you'll notice they have multiple weapon systems for different purposes. For instance, reference 22, the M2 Bradley fighting vehicle is expected to fight infantry, hardened and non-hardened structures, and tanks, as well as even aircraft. Though in general you usually have tanks fight other tanks, it is still an expectation that this will happen. It is therefore equipped with the following weapon systems. TOW anti-tank missiles. a 25mm main cannon, 2 coaxial 7.62mm machine guns, countermeasures for missiles, and with ERA armor when heat shells are fired from the main guns of tanks. In addition to this, it comes with the following optional weapon systems. A quad anti-aircraft Stinger missile launcher, which can replace the tow missile or be added on top of them. A mortar system with a GPS guidance unit. An engineering anti-tank, anti-barbed wire, and trench-building equipment variants. There's even a multi-rocket launcher system for artillery bombardment that can go on a Bradley. Yes, all of these weapons have different targets they engage to destroy. All of these weapon systems are made for different situations, but they can all be mounted on the same vehicle. Think about this. Why wouldn't you equip a mech if it's going to fight other mechs, vehicles, helicopters, jets, infantry, aircraft, battle armor, dropships, naval vessels, and occasionally a space warship with a bunch of different weapons to engage all of that? If you have a weapon system that had to engage all of that, you would equip it with dozens of different weapons, even modular ones. Omnimex, I'm looking at you. For the purpose of engaging different targets. Also, this should tell you, yes, a single mech can equip all of this weaponry. Let's take a look at the M1 Abrams main battle tank. Look, I'm American. I'm going to pick the Abrams because it's the easiest thing I can get references to, and it's the thing I've seen the most and had the most experience with. Bite me. It has a 120mm anti-tank gun, a 25mm coaxial weapon, or a 20mm depending on the variant, and a 50 cal machine gun coaxial weapon, in addition to a commander's machine gun that can be a 7.62 or a 50 cal. You can also mount tow missiles on the side, Stinger missiles on the side. There's a variant that comes equipped with an infantry-run mortar, and there's a hull version that we call the Paladin that has a 155 artillery cannon and a whole lot less armor. So yes, weapon systems of this size, you want to have the ability to engage a whole lot of different targets because they are going to run into them. Tanks are going to fight infantry, other tanks, artillery, rabbits, insurgents, insurgent rabbits, helicopters, artillery positions, hardened bunkers, Mountain Bunker Jones's bunker, and basically everything you can find on the modern battlefield. There were even tanks in World War II to shoot at ships. Reference 23. So all of this information taken into account. Yes, you want mechs with autocannons, LRMs, SRMs, machine guns, lasers of all sizes, PPCs, flamethrowers, and whatever else you can mount on them that can be classified as DACA, Zappa, or Kaboom Boom. So, in conclusion, what do we actually lack? Can we really do this? All this together, one day we might try out big mech robots to fight each other. Reference 24. We've already done that. The military minds at present do not believe they are practical weapons for a variety of reasons. Reference 25. But if you ask me, I think there's going to be something to be explored here when these machines of war are able to move at 70 kilometers an hour, and we have the control system that you would expect to have, such as those you see in Battletech, where mechs duck, dodge, and weave around each other while still being able to shoot at each other. At the very minimum, I foresee the possibility of the Solaris Arena being a reality. Reference 24. It's all food for thought. If we ever want the Battletech level of stomping murder robots, we need to figure out how the neural helmet works, and we need to harness the power of the sun itself. I mean, fusion reactors. But once you get these keys figured out, you could totally have Battlemechs and Gundams stomping around, the things restraining how our energy technology and medical technology, not so much our weapons technology, structural engineering, or technology needed to create Myomer bundles. It is strictly our medical knowledge and our knowledge of energy technology that is keeping us restrained for the moment. Hopefully this has shed some light on the creation of your very own Battlemechs. Now, if you'll excuse me, I have to decide if I'm getting into the Wolverine or the Warhammer. So, yes, here's the credits. The people who make this possible. Yes, I bought all of these books in the description. I read all of them and reread them actually for this particular video. Yes, I read all of these articles. I even attended a couple nuclear physics class in the past, as well as an up-to-date master's course online. Building this video required a solid month of just reading on medical advancements, nuclear fission, nuclear fusion, nuclear principles, computers and electronics, as well as learning how ships work in motion. You can thank all of these people for that. If you want more videos like this, I need to be able to fund them. So help me out here. I would, if you want me to do more Battletech-centric videos, sweet, I'll consider it, but you need to let me know. This video needs to look like you guys want this. This is an experiment on my part, outside of the realm of 40K, outside of the realm of ponies, and anime, to see if you want me to try to explain stuff from the Battletech universe. There's a whole lot of stuff I could have gone over, like how Battletech autocannons work, how ammunition feeds work in Battletech, how a particle projection cannon actually could be built. What about how lasers would work on a modern battlefield that are capable of melting through armor? All sorts of stuff. And I just chose not to at the moment. Say something in the comments, drop likes on this video or videos like it, that tells me that this is what you want me doing when it comes to my scientific research. In the meantime, next what I promised, the reason why the original MechWarrior 5 never came to fruition, and is there any real hope of getting a real MechWarrior game anytime soon? Because let's face it, the MechWarrior 5 we got is horrifically subpar. The possibilities are even better than I realized for these two things, though, but that's a future video. Good night for now. Thanks for coming. See you in my streams on Twitch or on my Discord. Links are in the description above my bibliography. And if you want more projects like this, like I said, Patreon. It funds the audiobook, it funds this research, and honestly, it's not quite enough. I constantly am diving into my own pocket to pay for stuff, particularly access to certain books or paying certain voice actors to do the audiobook work. So thank you for supporting me as much as you can. Thank you for helping me. The last thing I want to hear from you guys, however, is that you're not eating or going to the doctor or something because you wanted to pay for my research instead of taking care of yourself. Seriously, make sure you are 100% certain that you want to just hand me money, or any YouTuber or any online personality money, to make your content. Make sure you can afford to do that before you do it, and absolutely check it every month, because I'm going to be checking on you every time I get the chance to ask you, are you sure? Anyway, thanks for watching. Class dismissed.